have to determine some limits. The first one, tangent x minus x divided by sine x, and x is approaching 0. This looks like the special formula we've seen, but we have a difference in the numerator. First of all, we can rewrite this as tangent x divided by sine x minus x divided by sine x. Both times we need the limit for x approaching 0. What else? We know that the limit for x approaching 0 of tangent x divided by x equals 1. So it would have been nice if we had an x in the denominator. But if we place 1 in the denominator, we have to multiply the numerator by x as well. No problem at all, because tangent x divided by x when x is approaching 0 is approaching 1, and the same for x divided by sine x. So the first limit equals 1. Next one, x divided by sine x is also approaching 1 when x is approaching 0. So we get 1 minus 1. The result is 0. Next one, x squared x squared multiplied by cosine 3 over x. We know that a cosine is always a number between -1 and 1. So cosine of 3 over x is a number between -1 and 1. But we need more. We need x squared multiplied by cosine. So we can multiply each side of this inequality by x squared, and we get x squared cosine is a number between -x squared and x squared. We need the limit. So we will take the limit of everything we see, and then we get the limit of -x squared is less than the limit of x squared cosine is less than the limit of x squared. This looks like the sandwich rule, because we know that the limit of x squared and the limit of -x squared are 0. So the limit we are looking at should be a number between 0 and 0. The only possibility is 0 itself. Okay, this is an example of the chain rule. If two functions have the same limit and the third one is lying between them, should have the same limit as well. And last exercise, the limit for x approaching infinity of r cosine of a fraction. Because r cosine is a continuous function, we can rewrite this as r cosine of the limit of the fraction. But now we have the limit of a rational function when x is approaching positive or negative infinity. And when x is approaching infinity, we know that we only have to look at the terms with the highest exponent, both in numerator and denominator. So we have the limit of x multiplied by square root 3 divided by -2x. So we get r cosine of negative square root 3 divided by 2. Okay. So the question is, well, this is not going well. Let's try this once more. This looks like a circle. The question is, find an angle whose cosine is negative square root 3 divided by 2. negative square root 3 divided by 2 on the x-axis. We know that there are a lot of solutions, but it's our cosine function. We need to find an answer between 0 and pi. So there's only one solution. We know that the cosine of pi over 6 equals square root 3 over 2. So this is pi minus pi over 6, the supplementary angle, and this is 5 pi over 6.